What is meant by high rupturing capacity HRC fuse? The HRC fuse or high rupturing capacity fuse works similarly to a standard fuse in that the fuse wire can only carry a set amount of short circuit current. It burns if the flow is higher than this. Glass or any other form of chemical component is used to make HRC fuses. Ceramic metal caps with flexible silver wire are used to secure the fuse's ends. The wire, which would otherwise be the fuse's element, is surrounded by a sizable quantity of interior space. The HRC fuse or high rupturing capacity fuse is uniform and has the property of having a very quick trip time under high pressure current. Similar to this, a low fault current results in a prolonged break time. Since it operates with high accuracy and dependability, it provides an advantage over a typical rewirable fuse. Normally, distribution networks and electric motors are protected by HRC fuses. Construction of HRC fuse. A ceramic-like material with a body capable of withstanding high heat makes up the HRC fuse. On this ceramic body, the end caps are made of metal. A substance that is currently containing a silver is connected to this. Inside the fuse body is a powder containing the materials that will be used, such as quartz, plaster of Paris, dust, marble, chalk, etc. Overheating of the essence cannot be caused by noise sources in the current. The heat generated evaporates the element that has been dissolved. The filling power and the silver vapor will undergo a chemical process that creates a high resistance material that will aid to lessen the arc inside the fuse. Because of their low resistance, copper or silver are frequently employed in fuses. Typically, a fuse element has two or more pieces that are joined together by a tin. Tin's melting point is 2400 degrees C, which is lower than silver's melting point of 980 degrees C and keeps fuses from heating up to high temperatures in short circuit and overload situations. Working principle of the HRC fuse. Normal operating conditions prevent the current from producing enough heat to melt it. If more current flows than the fuse's limit, the fault current melts the fuse's element before it reaches its peak. When a fuse is overloaded, the component that makes up the fuse does not melt, but if the condition persists for a while, a substance like eutectic will melt and damage the fuse element. When the fuse is experiencing a short circuit, the thinner portions of the fuse element melt more quickly in a smaller space. Moreover, it will crumble before the eutectic substance. HRC has a good cause to include restrictions in the fuse's element. Types of HRC fuse. The following are the three common types of HRC fuses. DIN-type fuse, NH-type fuse and blade-type fuse. DIN-type fuse. These are found in a wide range of electric currents. It is utilized in various temperatures and has various qualities. These can be found in a range of voltages and are used to safeguard the transformer. Its cleansing ability is ideal for short circuit acts, transformers, gas-insulated switchgear, and feeder partitioning. Are all used in mining and the air. NH-type fuse. For low and medium voltage, NH-type fuses are employed. In conditions like overload and short circuits, this provides protection. This fuse guards against overload and short circuits and safeguards other devices as well as the beginning of the motor. These fuses are offered in lightweight versions with particular specifications. Blade type fuse. Plug-eye is another name for this type of fuse. A plastic body and two metal socket fitting caps are offered for the fuse. In automobiles, it is utilized as backup protection for motors, wiring, and short circuits. Generally, these have low cutoffs and are available in low weights. There are several sizes, forms, and current ratings of blade-type fuses available. Characteristics of HRC fuse. It possesses the three following important characteristics. Cutoff characteristics, I-dot characteristics and time current characteristics. Cutoff characteristics. The HRC fuse's cutoff characteristic is the graph that depicts how current and voltage change over time immediately following a malfunction. When a fault develops, the fault current has a significant positive peak, but the fuse melts before it reaches its peak. Prospective current is the name for this current. Cutoff current is the current at which a fuse blows and an arc begins. When a fault happens, the voltage briefly drops, and when the fuse melts and an arc forms, the arc voltage increases to a level that is several times greater than the supply voltage. This is entirely dependent on the cross-section and length of the fuse. The recovery voltage returns to normal when the arc entirely disappears. Here, the arc entirely disappears. I-dot characteristics. I-dot characteristics reveal details on the timing of arc quenching and the heating effect brought on by pre-arcing current. When the fault current is interrupted, the I-dot characteristic indicates how much energy is liberated and transferred to the devices that need to be protected. Time current characteristics. The time current characteristics of the HRC fuse are the line drawn between the fault current and operating time in the case of the HRC fuse. The inverse time current characteristic of the HRC fuse is present. Accordingly, the fuse's operational time reduces as the fault current's value rises. Selection of HRC fuse. These elements should be taken into account while choosing an HRC fuse. Application type, cable protection, motor protection. System voltage. Current at full load. Inrush current and non-fault overload current for motors. Maximum short circuit current and potential fault circumstances. Periodic current curve. Size. Cutoff curve. Advantages of HRC fuse. Cheaper than circuit breakers with the same breaking capacity. Easy installation and simplest construction. No maintenance is necessary. The fuse has a high breaking strength. Reliable in their performance. It doesn't decrease performance over time. Faster and more reliable operation. Not impacted by external factors. Used to eliminate both big and small values of fault current. The fuse offers trustworthy discrimination. Due to its inverse time current properties, it is suitable for overload protection. Disadvantages of HRC fuse. This fuse does not support interlocking. The arc-connected switch is impacted by the heat it produces. Cannot be used again once the fuse wire melts during usage. After each operation, replacement is required. Adjacent contacts becoming to heat. Application of HRC fuse. High voltage switchgear is shielded from short circuits by HRC fuses. For NCB backup protection. Motor stators also require this kind of fuse. Required to protect electrical devices like motors, transformers, and cars. High selectivity radial and ring networks.